guys! Hope you all have had a great first full week of classes. We've had a couple of questions come up in SI about how to name compounds, such as when to use numbers, when to have what particular ending. So I thought I'd just kind of make a really informal video to explain some of that a little more in depth, and I thought I'd share it with the whole class just in case it may be helpful to some more of you all who have questions. But anyways, now back to the point, naming compounds. And what we're really kind of doing right now is learning how to speak the language of chemistry so that we can actually get into it a little more in depth and do some chemistry in the weeks to come. But so far, we need to come up with a naming system because there are just too many compounds for us to give them a different name. So that's what chemists have done through the years, is come up with a system to assign particular names to different compounds. And so the compounds we focused on naming so far are ionic compounds, and then today in class we also got into some with covalent compounds. Now, just to remind you all, ionic compounds are compounds that are formed by bonds between ions. And an ion is just an atom with a charge. Normally when we see atoms on the periodic table, they have a charge of 0 because they're neutral. The number of electrons equals the number of protons. But let's zoom in on potassium, for example. This K right over here. Potassium can form a cation because it can lose one electron. And so here it is as an ion, K+. Alright, so this is an example of a cation. I'm trying to do the videoing with one hand, so I apologize if it's a little shaky. So there's an example of a cation. Now let's go over here to the right hand side of the periodic table and pick an example of an anion. Let's just take Cl, chlorine. And what can happen with chlorine is that it's capable of gaining an electron. And so anions are negatively charged. So there we have a positively charged cation. If you want help to remember that, that T kind of makes a plus sign. So cations are positively charged. And then anion kind of looks like onion, which makes you cry, you know, kind of think negatively. So you can attach those if you need a little reminder. Alright, so when you have compounds that are formed by two different ions coming together, those are known as ionic compounds. And there are two different ways you name them. Alright, the first kind we're going to talk about are type 1 compounds. Okay, and what we'll see sets these compounds apart is that it depends on where the atoms are coming from on the periodic table. You'll notice here, try to pan over. Just want to point out a couple of features. Say the two groups on the left hand side are groups 1 and 2, and then if we jump over this yellow block in the middle and then go on to groups 13, 14, 15, 16, 17, and 18, these two plus these groups over here are known as the main group elements. We do a lot of chemistry with these guys. Okay, so these are the main group elements. Now this yellow block in the middle, these are known as the transition metals. And transition is kind of a good word for them because they kind of transition us from these two groups all the way over here to these guys on the right. But because of that, these have some mixed properties. The guys on the left and the right have charges that are a little more set in stone, so we don't try to mess with them too much. But the transition metals, they can kind of go back and forth. They have a little more flexibility as to what ions they form. So, with that in mind, let's return to our discussion. So these type 1 compounds, these are compounds that are formed using atoms from the main groups. Example of these on the left paired with these on the right. And just to remind you all, ionic bonds are those that are formed from metals and nonmetals. When you follow the trend on the periodic table, most metals kind of reside on the left and most nonmetals on the right. But just a reminder about ionic. So when you have a metal and a nonmetal that are both from the main groups, here's the way you name them. Let's just pick an example. I'm going to use some examples from the textbook. So let's just start with the simple one. Salt. NaCl. Alright, so let's check. First of all, we have a metal bonding with a non-metal. Okay, so check. We know it's ionic. So now let's see if these elements are from the main groups. So we go to our periodic table. And alright, so sodium, that's in group 1, so that's a main group element. Very good. And then over here, chlorine, that's in group 17, also a main group element. So great, we know we're on track to name them. And in this particular type of compound, the cation, whatever forms the positive charge, is always going to come first, and the anion will always come second. And that's just what we see here. Because if we were to break these up a little bit, it'd be Na plus and Cl minus. But when they come together, those charges cancel each other out, and it's a neutral compound. Okay, so back to the naming. So you first look at the cation, and you simply write its name. So this is the element symbol for sodium. So we're just going to write sodium. Okay, so that's our cation. Now we're going to transition over to the anion. So while the first part of the name didn't change, we do have to make a slight adjustment to this last part. The name of this element is chlorine. But to denote that this is an ionic compound and that this is an anion, we're going to take off this I and E and replace it with IDE. So instead of sodium chlorine, this becomes sodium chloride. Alright, and so let's pick another example. Let's take this one. Calcium and sulfur. So we check and we know calcium, yep, that's a metal. Yep, sulfur's a non-metal. So okay, we've got an ionic compound. Then we go to our periodic table and we want to see where they're coming from. So here's calcium. It's a group 2 metal, so yep, it's a main group element. And then if we look over here for sulfur, there he is. He's also in the main group. So good, we know we can still use this same set of type 1 naming rules. So just like before, the cation, this time if we were to break them up, it would be Ca2 plus and sulfur 2 minus. Because calcium's in the second group, on the left-hand side, it can give away 2 electrons. And so when it loses electrons which are negatively charged, it becomes more positively charged, so hence the 2 plus. But sulfur, on the other hand, it wants to gain 2 electrons. So as it acquires more negative electrons, it becomes more negatively charged. Alright, so let's follow the same rules as before. We take our cation and simply write the name for the symbol. This is calcium. calcium. Okay, and then we take the second element, and its name is sulfur. But again, we don't just leave it as sulfur. We have to add the IDE as before. So instead of sulfur, this becomes sulfide. There we go. So the name of this compound is calcium sulfide. Alright, so this is the rules for naming type 1 ionic compounds. I'm going to kind of keep the videos a little shorter. I'm going to stop it here and then I'll start a new one for type 2.